Hello everybody, and today we're talking about angle relationships and triangles. Before we get too far, let's talk about what makes up a triangle. Okay, think of the base word there, tri, meaning 3, and angles, well, we know what that means. Those are angles. So, a triangle is made of 3 angles, but it's also made up of 3 sides. Alright, so it's our job to determine which of the following polygons are in fact triangles. Okay? So this should be pretty simple. 3 sides, triangle. 4 sides, not. 3 sides, triangle. 4 sides, not. And this star is obviously not a triangle. Okay? Now, we need to label the vertices, sides, and angles for this triangle. Now, one vertex is point A. Another vertex is point B. And the last vertex is point C. Now, for our sides, we have line AB, we have BC, and AC. You could also write this BA, CB, or CA. That's fine. And then last but not least, the angle measures. This would be angle A. We also have angle B and angle C. Alright, so what do all the angles of a triangle add up to? It's 180 degrees. You need to know that. Now, there's an additional video on top of this one that you should watch. It's Mr. T's math videos, and he discusses why the angles of a triangle add up to 180 degrees. So please watch that when you're finished with this video. Alright, so we need to find the missing angle. Okay? Missing angle here, remember that the angles need to add up to 180 degrees. So 180 minus 110 minus 40 is going to give us 30 degrees. So the missing angle here is 30 degrees. You can always go back and check your work by adding 110, 40, and 30 to verify that you have 180 degrees. Now on this one it says find the missing angle, but we've only been given one angle of 40 degrees. However, this is an isosceles triangle. In an isosceles triangle, the base angles are congruent. So we can call this x and x. They're the same. So x plus 40 equals 180. Okay, we want to go ahead and combine my like terms. So 2x plus 40 equals 180. Subtract 40 from both sides. 2x equals 140, so x has to equal 70 degrees. Okay, so both of these angles here and here are 70 degrees. Alright, in this problem it says solve for x. Notice it did not say find the missing angle. So whenever we have x, we're done. We don't have to plug it back in. Alright, so this angle right here is 90 degrees because the little box, right, means that it's a right angle. So 90 plus 70 plus 4x equals 180. Combine your like terms. 90 plus 70, that should be 160. Subtract 160 from both sides. So 4x equals 180 minus 160 is 20. Divide both sides by 4. X equals 5. Okay, so we are actually done there. We don't have to plug it back in. If we wanted to check our answer, we could plug in 4 times 5 is 20. 20 plus 70 plus 90 is 180. I know I did this correctly. Alright, solve for x and then find the measure of a. So now we got to plug it back in once we have it. All of these must add up to 180, so x plus 66 plus 55 plus x plus 79 equals 180. Notice that I've put all 3 angles, you add them all up, and equals 180. So we're going to combine our like terms here. We're going to add our x's. Okay, x and x is 2x. Okay, 66, 55, and 79 are going to give me 200. When I subtract 200 from both sides, I get 2x equals negative 20. Divide by 2, x equals negative 10. When we plug negative 10 back in, negative 10 plus 66 is going to give me 56 degrees. It's okay to have a negative x value, but it's not okay to have a negative angle measure. Okay, then what you could do is also plug this back in here. 55 minus 10 is 45. So 45 plus 56 plus 79 gives us the 180 that is required of all triangles. Alright, now the third angle theorem says if two angles in one triangle are congruent to the two angles of another triangle, then the third has to be congruent to each other. Here's why. If this is, say, 20 and 100, then this is also 20 and 100. Basically, I would do the same thing we've been doing for the last couple of problems. 180 minus 100 minus 20 gives me 60. 180 minus 100 minus 20 gives me 60. So if the two angles are congruent, then the third is automatically congruent. This is going to be very important when we talk about angle-angle similarities. Alright, so let's use that example here. What is the measure of angle A? Given that angle B is congruent to angle E, and angle F is congruent to angle C, by the third angle theorem, angle A is 40 degrees. Now this is easy to see because they look like reflections of each other, but what happens when I have to rotate something? Okay, notice angle B is congruent to angle E again, D is congruent to angle A, which means that F is congruent to angle C. So I need to set y squared equal to 3y squared minus 72. Okay, we can subtract 3y squared, and I get negative 2y squared equals negative 72. Okay, slide down a little bit. Divide both sides by negative 2, and I get y squared equals 36. Now, how do you get the square off of the y? The opposite of that is square rooting. Okay, so y should be equal to plus or minus 6. Now, going back up here, okay, I need to plug it back in. 6 squared is 36. 6 squared times 3 minus 72 is also 36 degrees. So I can either put in plus or minus 6, either negative or positive, and I'm going to get 36 either way. Because when I square negative 6, it's going to become a positive 36. Make sure when you're typing it in your calculator that you're putting it in the parentheses. Otherwise, your calculator will think you just want to square the 6 and then multiply by the negative. Alright, a triangle by any other name would smell just as sweet. We name triangles based on their sides and their angles. So, given the sides of a triangle, if they are all the same, they are an equilateral triangle. If two sides are equal, then it's an isosceles. And if no sides are equal, then it is a scalene triangle. Now, based on the angles, okay, I'm going to slide this up so you can see. If all the angles are less than 90, we call it acute. If one angle is 90, it is right, and if one angle is larger than 90, it is obtuse. Makes sense. Alright, so a couple vocabulary words. Interior means that it's inside of the polygon. In this case, angle 1, angle 2, and angle 3 are all in the interior of the triangle. Exterior is outside of the figure, so in this case, angle 4 is your exterior angle. Now, remote interior angle. This is important because we're going to talk about the exterior angle theorem. Remote interior means non-adjacent to the exterior angle. So in regards to angle 4, angle 1 and angle 2 are the remote interior angles, because 3 is adjacent, so we can't say that it's a remote interior angle. Alright, so here's the exterior angle theorem. It says angle 4 is equal to angle 1 plus angle 2. Okay? Using the exterior angle theorem, let's solve. Here's my exterior angle, 2x plus 4. This needs to be equal to x plus 50. Notice they've already set that up for you. So what they do here is they need to solve for x. Now they did a lot of work in one step. So I'm going to take this down here and I am going to solve it this way. First off, distribute the 2 on side by the distributive property. Okay, then I would subtract 8 from both sides. Subtract x from both sides. And you get that 42 is equal to x. Now plugging it back in, the exterior angle 2 times 42 plus 4 is going to be 92 degrees. That is your answer. Okay, remember you're not just looking for the value of x. You have to plug it back in. Alright, find the measure of the angles. So the exterior 2x minus 11 will be equal to the 2 remote interior angles added up. So 2x minus 11 equals x plus 72. Subtract x, add 11. Alright, so I get that x equals 83. However, we need to plug 83 back in. So 2 times 83 minus 11 is 155 degrees. Alright, exterior angle is 5x plus 15. These are my remote interior angles, so I'm going to add them up. 30 plus 3x plus 1 equals 5x plus 15. So doing some algebra here, let's go ahead and combine the 30 and the 1. So I have 31 plus 3x equals 5x plus 15. Subtract 3x from both sides. Subtract 15 from both sides. 2x equals 16. And then divide by 2, x equals 8. But remember, we're not just looking for 8. We need to plug it back in. So 5 times 8 plus 15 equals 55. Alright, that's it for today and the angle relationships of a triangle. Our next video will be about congruent triangles.